Okay, so here we're going to look at 3 blood type problems where you need to figure out the answer with Punnett squares, just for a little bit more practice. Okay, so in this problem, I'm just going to move myself here. Sally has type A blood, and she says John, who has type AB blood, is the father of her child. She wants some child support. The baby has type O blood. Will she be successful? Okay, well, let's figure that out. She's, whoops, to do that. Okay, set up this Punnett square here. So Sally having type A blood, we don't know for sure. We just know her phenotype. We don't know whether her genotype is homozygous or heterozygous. So let's just work with what we know first of all. So I'll put in her type A blood there. We don't know what this one is quite yet. John, we know his because he has type AB blood. So let's put him over here. There's his A, and there's his B. Okay, so let's go ahead and do what we know. So first of all, here, this is one possibility for their baby. Could be homozygous dominant for type A blood, in which case not type O. Or this is another possibility. Could have got the A from Sally and the B from John, in which case the baby would have type AB blood. Now, I'm just going to do this because we don't know what her, I'm going to change my pen color just to make this a bit easier. So this could be, this is an or situation because we don't know whether she is homozygous for her type A blood. So let's just put that in. Or she could be heterozygous for her type A blood. So this way we can solve it both ways. So now the baby could get the A from John and an A from Sally, if she had an A. The other possibility is she has an I, so we'd still get the A from John, but this time would get the I from Sally. Now in this case, the baby's going to have type A blood, and in this case, the baby's still going to have type A blood, but it's just going to be heterozygous for the type A blood. Now, here, baby's going to get the A, if she has a dominant A, from Sally and a B from John. Baby's going to have type AB blood, or baby's going to get the B from John and a recessive allele from Sally and could potentially have type B blood. So depending on this unknown, which we're not sure what's going to happen, the baby is either going to have type A blood, type B, AB blood, or possibly type B blood. But there's zero chance that this baby is going to have type O blood. So John is not the father, and she probably should get child support from someone, but not from John. Okay, let's try another problem. Julie has type AB blood, and she's married to Ben, who has type O blood. Okay, so here's Julie. She's got type A B blood. And she's married to Ben, who has type O blood, so that means he has 2 recessive alleles. They had one child together and adopted a child. Which child was adopted and how do you know? Their daughter Susie has type O blood and their son Georgie has type B. So which child was adopted? Oh, well, that's redundant. I asked that twice, but that's fine. We want to know which child was adopted. Okay, so let's just do their Punnett square and see what's the possibility. So there's the A from Julie and the recessive allele from Ben. Okay, and now here, Julie could give a B and Ben could give his recessive allele. And the same sort of situation here, actually exactly the same, Julie giving an A, Ben giving a recessive allele. Here, Julie giving a B, and Ben giving a recessive allele. So Susie has type O blood, just basically just like Ben, but Ben, married to Julie, cannot have a child with type O blood. So Susie has to be adopted, and Georgie, having type B blood, well, 50% of their children are going to have type B blood. So Georgie is their biological child. Okay, one more problem. So in this one, Margaret has type B blood. We don't know if she's homozygous or heterozygous, and her boyfriend has type A blood. Again, we don't know if he's homozygous or heterozygous. They were somewhat shocked to learn that their new baby has type O blood. They wonder if a mistake was made at the hospital. Can you put their mind at ease? So let's try. So the first thing we might want to do is start on a Punnett square. Oh, my goodness. Okay, there. Okay, so Margaret having type B blood, she could be homozygous or heterozygous, which is why I made two squares, because I don't know for sure. I want to try it both ways here. So she has type B blood. I'll put a B there. Remember, I'm just doing two simultaneously here. And if she's homozygous, then she has two dominant alleles. If she's heterozygous, she's got a dominant B and a recessive allele. And Henry, he's got type A blood. Okay, let's put Henry here as a homozygous dominant for A blood and heterozygous here. Because the problem doesn't tell us this information, whether they're homozygous or heterozygous. And actually, we could do 4 Punnett squares because one could be heterozygous and one could be homozygous. Hopefully, we don't have to, but we'll go through this and we'll see. Okay, so in this case, get an A from Henry and a B from Margaret and have type AB blood. Same thing here. I'm just putting the phenotypes in here. It's a little difficult with my mouse to draw all these genotypes, so I'm just going to put in the phenotypes. Okay, so A, B here, and A, B here. So if they are both homozygous dominant for their blood types, then we can see there's 100% chance that their child would have AB blood. That's not type O, so that wouldn't be good. Let's see what if they're both heterozygous? Okay, so if they're both heterozygous, getting an A from Henry and a B from, oh, I'm putting in genotypes again now. Not very consistent, but I guess I may as well finish this off like that. Okay, so in this case, got an AB genotype. Now, in this case, getting an A from Henry and the recessive allele from Margaret, the child would have type A blood. Now, in this case, getting a B from Margaret and a recessive from Henry, the child would have type B blood. But look at this. If the child gets a recessive from both parents, then that child will have type O blood. So I don't think the hospital made a mistake. And it's good because now we don't have to do up any more Punnett squares for this problem because we've solved it. So the child is, well, most likely theirs. And that's the 3 problems that I wanted to do with you today. All the images on this presentation were Creative Commons and copyright free to use.